So in this video we discuss about the numerical related to the electrochemical series and standard electrode potential. So in the previous video we have already discussed about the what is the electrochemical series and what are the application of the electrochemical series. So now we start about the numerical. First, I again repeat the formula how we can calculate the standard electrode potential of any cell. So we use, there are different types of formula, but here we mainly use the E naught cell equal to E naught cathode minus E naught anode, means standard reduction potential of cathode minus standard reduction potential of anode. We use only the standard reduction potential in this formula. So if we start the numerical related to this, then numerical is first question is a cell is prepared by dipping a copper rod in 1 molar copper sulfate solution and a nickel rod in 1 molar nickel sulfate solution. The standard reduction potential, see the standard reduction potential of copper electrode and nickel electrode are 0.34 volt and minus 0.25 volt respectively. So the question is, what will be the cell reaction and cell representation? What will be the standard EMF of the cell and which electrode will be positive? So in this question, if we proceed towards the solution, first you identify which metal is given. Here the metal given are the two metals. First is the nickel and second is the copper. So if we proceed towards the electrochemical series, so in electrochemical series, if you see the electrochemical series, the nickel comes first and copper comes after the nickel. It means that nickel metal act as the anode, more reactive metal act as the anode. The metal in the electrochemical series which comes first act as the anode, and the metal which comes after the hydrogen or which is present in the lower in the series act as the cathode. So nickel anode and copper cathode. First you identify anode and cathode. If you able to identify anode and cathode, then the question becomes very easy. Now you write the reaction related to this. If I want to represent the cell reaction or cell representation related to this, nickel electrode dip in the nickel sulfate solution, and copper electrode dip in the copper sulfate solution. Now nickel sulfate, how much charge present on the nickel from the nickel sulfate? Nickel 2+. It means that the reaction takes place at anode reaction takes place. Nickel lost the 2 electron and converted into nickel 2+. Nickel lost the 2 electron and converted into nickel 2+. The electron which is lost by the nickel transfer through the wire to the copper electrode. Now what happens in copper sulfate solution? How much charge on the copper? Copper 2+. This copper 2+ gain the 2 electron and copper deposited on the copper electrode. Now at the cathode the reaction takes place. Copper 2+ plus 2 electron gain the electron and converted into copper. If we write the overall reaction, reactant side represents the reactant side and product side represents nickel plus copper 2+, nickel 2+, and then copper. 2 electron here, 2 electron here, they are cancelled. One thing you remember that the number of loss of electron remains equal to the number of electron gain for balancing of the reaction. If the number of electron loss and number of electron gain are not equal, it means that your cell reaction not correct. So if you want to represent the correct cell reaction, then you also balance the number of electron. So this is this cell reaction. Again I repeat, anode more reactive, anode oxidation, and cathode reduction. So at anode, loss of electron, at cathode, gain of electron takes place. Now, second question is, first is the what will be the cell reaction and cell representation. Now, how we can represent the cell representation? Cell representation, we discuss about one trick, A, B, C. A means anode, A means anode, B means bridge represented by two parallel line, and C means cathode. So A, B, C. A anode, B bridge, C cathode. So first write the anode reaction. Anode reaction, nickel converted into nickel 2 plus. So nickel, arrow sign represented by slash sign, nickel 2 plus, then for sold bridge to parallel line, copper 2 plus, then it converted into copper. Now this is the cell representation, A, B, C, cell representation. Or you can also write nickel 2 plus means nickel sulfate. So this is also correct, NiSO4, and copper 2 plus means copper sulfate, CuSO4, and copper. Both the cell representation are correct. So this is the first part, what will be the cell reaction and cell representation. Now, secondly, what will be the standard EMF of the cell? What will be the standard EMF of the cell? So we use this formula. Given in the numerical, the given value are standard reduction potential of copper electrode. The standard reduction potential of copper electrode given 0.34 volt, and the standard reduction potential of the nickel electrode given is the minus 0.25 volt. So we know which is anode, which is cathode. So this is the nickel is the anode, nickel is the anode, and copper is the cathode. So apply the put these value in the formula. E naught cell equal to E naught cathode, which is cathode copper. So put the value of the copper 0.34 because SRP given and we require the SRP in the formula, minus anode value SRP given, standard reduction potential, put the value minus 0.25 volt. We solve with this, 0.34 minus plus 0.25, so value becomes 0.59 volt. So this is our answer. Now in this question, if I add one extra question, that this is the feasible, spontaneous or non-spontaneous. So if E naught cell is positive, then reaction is spontaneous, and if E naught cell is negative, then reaction is non-spontaneous. So in this E naught cell is positive, it means that reaction is spontaneous. Again we remember that more reactive metal displays the less reactive metal, so nickel displays the copper sulfate solution, so this reaction takes place. So by the value of EMF, by the we explain the spontaneity of the reaction. By the reactivity of metal, we explain the spontaneity of reaction. So by these things we can explain. Third is which electrode will be positive, which electrode will be negative, which electrode will be positive. So we again able to give the answer of this question, that nickel electrode is negative and copper electrode is positive, means anode is negative and cathode is positive. So this is the first question. Now the second question, can a nickel spoon be used to stir a solution of silver nitrate solution? Spot your answer. What is the meaning of this question? Question is, can we stir the silver nitrate solution? This is the silver nitrate solution by the nickel spoon, by using the nickel spoon. So by using the nickel electrode, nickel spoon, can we stir this solution? So first we discuss the simple thing, nickel plus AgNO3. So if we see the electrochemical series, so from the electrochemical series, we find out that nickel is the more reactive and silver is the less reactive. So nickel more reactive displays the silver from the silver nitrate solution. So reaction is spontaneous, reaction is feasible. It means that if we want to dissolve the silver nitrate by using the nickel electrode, then nickel electrode undergo decomposition. So it is not possible to stir the solution of the silver nitrate by using the nickel electrode. This is the first method, simple method, first method by which we identify. Second method is, if the given value is electrode potential value is given, then you solve the E naught cell value. How you can solve the E naught cell value? E naught cell, apply the formula E naught cell equal to E naught cathode minus E naught anode. So for this you require that which metal is anode, which is cathode. So again use the electrochemical series. In electrochemical series, nickel comes first, so nickel is more reactive, so nickel is the anode and silver is the cathode. This is the cell reaction. Nickel react with the silver nitrate, form the nickel 2 plus and silver. Cell representation. How we can write the cell representation? First I write the separate reaction. Listen, at anode oxidation takes place. We know about this nickel. Oxidation nickel 2 plus 2 electron. Why I write here the plus 2? Because in the question, see, nickel 2 plus nickel means the E naught value given nickel 2 plus R. And if I write the cathode reaction, then cathode reaction is reduction. Ag plus, it gain the 1 electron and converted into Ag. Now see, in this reaction, the 2 electron loss. But at cathode reduction, 1 electron gain. So balance this equation. For balancing this equation, we multiply this equation by 2. So the reaction becomes 2Ag plus 2 electron and converted into 2Ag. So if we want to represent the cell representation, see, nickel arrow symbol represented by slash symbol, nickel 2 plus, then salt bridge, then Ag plus, and then Ag. Okay. So these are the cell reaction, cell representation. Now use the formula. This is the cathode, this is the anode. So put the value E naught cathode. Cathode means silver. See, this is the SRP value given. How we find out that this is SRP or SOP? See, Ag plus converted into Ag. It means that charge decreases. Charge decreases means reduction, and this is the SRP value given. SRP, standard reduction potential. So put this value 0.80 volt. Now minus E naught anode. Again nickel 2 plus converted into nickel. So SRP means this is again the SRP value given. We put the value minus plus, and the answer is plus 1.05 volt. It means that this reaction is feasible. Why? Because E naught cell positive. If E naught cell positive, then reaction becomes feasible. The similar question, third question is, can we store copper sulfate solution in a zinc pot? This is again a very simple question, and this is also asked in the 10th class. You have discussed about this question. You have already discussed in the 10th class also. So again, zinc. Can we store the copper sulfate solution into the zinc electrode? Can it is possible? So zinc is more reactive. How we can find out that zinc is from the electrochemical series? So more reactive metal displays the less reactive metal from their soul. So the compound formed is zinc sulfate plus copper. It means that we are not able to store the copper sulfate solution into the zinc electrode. So these are the question. Last question for your homework. That following facts are available. The which sequence is correct? This is the objective question. So try to solve this question, and if you have any problem, then you ask. Okay.